Hi everyone, this is Michal again, and today we'll go through the latest questions from the topic of meteorology. So we'll see 7 questions that have been seen in a bank and across all the EASA authorities in the past 60 days. So without any further ado, let's jump into it and let's see what EASA has prepared for us lately. Which of the following cloud types will most probably form when cold, moist air moves over a warm surface? So, of course, for cloud formation, we need some moisture. So, cold, moist air moving over warm surface makes a lot of sense. So, what is going to happen? So, I think what the examiners are referring to here is something called thermals. This can happen very often, and what this will produce are something that is called um, fair weather cumulus clouds, or just generally any cumulus clouds when you have a hot air bubble. So the moist cold air is getting warmed up by the warm surface, and of course, it is convected higher up where the cloud starts to form as the air reaches 100% saturation. And this will happen very often, especially during good weather days. So there doesn't have to be a lot of instability for these clouds to form. And especially, like I mentioned, if it's a very sunny and a long day, so you have a very warm weather. And then if there is some cold, moist, especially moist air advected, then these fair weather cumulus clouds can form, which don't really necessarily mean that there's going to be big thunderstorms, but they do form, and these are the sheep-like white circles in the sky. For question number 2, according to the following messages, a pilot approaching for landing to an airport reported something. Hmm. So for these questions, you always need to watch out for little traps, and there is a trap at the end of each of these sentences. So if you look at the first and the last airports, you can see at the very end there is a 4-letter code which stands for forecast. So of course, in the question, we are asked for a report from pilots. So of course, right away we can exclude the first two answers, the first two airports, as these are forecasts. Now, of course, we are approaching an airport, and we can see that we have the Saloniki and Athens in Greece. So the wind shear warning, and we have a microburst on approach to runway 16 reported by the A320 at a specific time, and so on. Of course, in the third answer in Athens, you can see that we have a wind shear in climb out, meaning a departure. So just like that, by eliminating the two answers from essentially the beginning, because of this little trap that is posed for us there, you can see that the other two are referring to either an approach or departure, and the question asks for approach, meaning Thessaloniki and microburst will be the correct answer in this instance. For question number 3, advection of very cold air over a warm sea current can cause. So advection of very cold air over a warm sea current will cause something called steam fog, or an Arctic smoke, it's also called. So this is the same exact phenomenon that I always think about it, as if you go out to the terrace during a cold day with a hot cup of tea or coffee, you will start seeing a lot of water vapor above your glass. And this is exactly what's happening here, and this is exactly what a steam fog is. So it's a hot or hotter body of water that has moist air above it, and that can add moisture to the air, and then you have cold air coming over, or just generally over it. So when you see steam fog, think about a hot tea, hot coffee, and a cold day, like you're sitting at the terrace during your winter day. So this will be it. Of course, advection fog is the opposite. So advection fog will be hotter air over a colder area, and frontal fogs will be always associated with a front, most usually in front of a warm front for the prefrontal fogs. So this is for the steam fog. Remember, steam fog is always cold air over a warm sea or a warm area, and then advection fog will be the opposite. For question number 4, during pre-flight planning, what documents are available to determine the EASA temperature deviation on the route at flight level 100? So always before your pre-flight briefing, you will check something called winds aloft chart, also known as wind and temperature charts. So this will show you different temperatures and winds, or their general strength and direction at a selected flight level. So this can be as low as flight level 50 to as high as flight level 400 or even higher. And these will be given usually by the Met Office for the general area of Europe. And they're good to cross-check with your other sources when you're doing your briefing. However, there is a little trap that I would like you to remember, and this is related to the temperatures. On these charts, temperatures are by default a negative. So if you see a temperature of 20, this means minus 20. If there is a positive temperature, there will be a prefix plus in front of it. However, if there is nothing in front of the temperature, this will be a negative temperature. Of course, TUFs, they are forecasts given usually by the airports about the upcoming or expected weather at a period of time. NOTAMs, they give info about navigates, about routes, about dangerous areas, about situation at the airport, not related to weather. And lastly, significant weather charts, they will show you areas of icing, turbulence. They will also show you some fronts. However, they do not give you information about winds and temperatures. So this will be it for that one. Now going into question number 5, the position of the Intertropical Convergence Zone. And of course, the Intertropical Convergence Zone is the zone where we have the highest inclination of the sun on our Earth, meaning the sun is heating up the surface the most over these areas. And this is also where this hot air is creating a lot of vertical air movement, which then can actually cause some tropical revolving storms to have to grow. And if they detach, if these very violent storms detach, then they can go over to Florida, India, and Australia and cause massive disruptions. So this is where the TRSs are actually coming from. And the Intertropical Convergence Zone, of course, spans across the globe and roughly follows the equator, however, not exactly. And this is because the water has a different heat capacity than land. And this is something to be remembered. And due to this intertropical convergence zone will behave differently over water because the water can keep and the oceans can keep the heat for longer than the surface, meaning it will be more stable over oceans and seas than it is over countries and land surfaces. And for this also reason, this is why it's more predictable over water than it is over surface. And of course, also remember for the questions that in summer, this ITCZ, it migrates to the north and then it comes back to the south during winter. So knowing this, we can look at the questions, show more variation over the continents than over oceans. Yes, and this is for the reasons we discussed. Um, depends on the activity of thunder, storm clouds. No, more north in January than in July. No, it will be the opposite. And this one as well. No, meaning the question, the answer at the beginning, the first answer is correct. For question number 6, with what type of cloud is heavy precipitation unlikely during the summer months? So of course, for these type of questions, it's the best to just go with the elimination process. We know that nimbostratus or any nimbo clouds, they are producing precipitation, and so do the cumulonimbus clouds, which are the ones associated with thunderstorms. So from the get-go, we can essentially eliminate 3 answers. And this leaves us with stratocumulus and altostratus clouds, which are not precipitation clouds by their nature. Stratocumulus can cause and produce some precipitation. However, generally these are not threats and definitely not something that will give us heavy precipitation. And the same goes to the altostratus clouds, which are the medium level clouds. And for the last question, 7, an aerodrome on the coast, so Faro, Portugal, reported the following. And we see here the code for the airport at 7th of the month at 6:50 Zulu time. We have wind blowing from 260 degrees 15 knots. And we see that our visibility is 100 only meters with fog reported and no reported vertical visibility. We see that the temperature is the same as dew point. This explains the fog. And also the QNH, or the pressure, is 1006. So what type of fog can you expect in Faro at this moment? So for the exams, there is a rule of thumb, of course, that if you are talking about a coastal airport or a coast, this most often will be advection fog, and this will also be the case here. So you can see that the coast means that we have an advection fog, and this is good enough for exams. However, you might ask, why not the other ones? So orographic fogs, we need to know about the terrain. Orographic fogs are mainly concerned with rising and dropping air due to terrain, such as mountains. Frontal fogs as well. We would need to have information of what is happening in the general area. So if there is a front, warm or cold front, usually warm front will bring us some fog, especially in front of it. And lastly, radiation fog, and this is something that we can exclude because of the very high winds here. So you have 260 and 15 knots. For radiation fogs, the wind has to be a maximum of around 5 knots. Otherwise, the wind will just dissipate the fog too quickly. And this is the main reason why we're not choosing radiation fog in this instance. Also remember that the wind means advection. Advection is nothing else but a horizontal movement of air, which is nothing but wind. So if we have stronger winds, this will mean advection, and for the reasons discussed, this cannot be radiation fog. However, this will be everything for today. Thank you so much for tuning in for today's class, and I wish you all the best with your meteorology exams, and I hope to see you in the next video. Bye-bye.